Good afternoon, everyone. I'm going to be talking with Dr. Kenny Broad today, one of the best explorers on the planet. Hey, Kenny, how you doing?
Hey, how are you? Sorry about
Good, good.
the.
Listen, man, thanks for joining us. It's great to have you on, and I know you're super busy. And are you in Miami, or are you in some obscure part of the world?
You don't consider Miami an obscure part of the world? Um,
You're
no,
right. Good point.
I'm in Miami, my ancestral village. Actually, I grew up here.
All right, awesome.
Uh,
Well, I'm going to do a brief introduction just while everyone's logging on.
okay.
We are fortunate to speak with Dr. Kenny Broad, who's a friend and colleague here at the University of Miami. He is world renowned as one of the greatest explorers on the planet. He probably doesn't want me to say that, but it's true. Former National Geographic Explorer of the Year for all of his work involving extreme scientific and filmmaking expeditions on all seven continents. He regularly collaborates with ecologists, climatologists, hydrologists, and psychologists to gather information about these rare environments. As background, he's published several high impact articles on topics ranging from risk perception to venomous snakes to natural resource management. He is a licensed U.S. Coast Guard captain, a commercial helicopter pilot, and holds multiple dive-in ratings. As I said, he's currently a professor at the University of Miami, where he directs the Abbess Center for Ecosystem Science and Policy. He's also co-director for the Center of Research on Environmental Decisions at Columbia University, where he received his PhD. He has been elected a fellow of the National Explorers Club, and again, here to describe scientific, extreme scientific filmmaking and what that entails and everything that he's discovered and just exactly how crazy he is. So, Kenny, it's a pleasure to have you on.
Hey, thank you. I'm super excited to speak with you, or it's the 6 shots of espresso that I had right before our call. One of the two.
One of the two. Well, yeah, just I guess tell us a little bit. I mean, because I've seen what you do, and it really is mind blowing. But give us a little background about what you do, why you do it, and what's the importance of that towards mankind.
Okay, that's a loaded question. I guess in the sense, let me start off with full disclosure that I can give you the very rational, post facto rationalizations for why I take these types of risks along with my colleagues underground. And there's all sorts of, there's uh, new findings in biology, so forms of microbial forms of life that can not only tell us about what was on Earth billions of years ago and how it led to sort of the evolutionary chain where we're at the very end of that deep timeline, all the way through to recovering speleothems, stalagmites. So we do a lot of work on climate change here, and we can look at the isotopic ratios among the different components of these geologic samples and reconstruct past climate and figure out what was going on before humans were influencing the Earth and the Earth's atmosphere. So there's all sorts of practical reasons. So some of it is, I think in the realm of philosophy and existential. What are the origins of life and where are we heading? What life might be on other planets? Because underwater caves, many of them have the unique water chemistry and other characteristics. So they're modern day earthly analogs for where we might want to search for life, and under the ice in Europa or other places like that. And then lots of stuff in between. So there's archaeology. These are time capsules. A great way to preserve fossils is if you put them underwater, anoxic, no oxygen, salt water. You can, for thousands of years, they'll remain unchanged. You can get DNA samples from them to try to reconstruct the natural history, but also human history through migrations around the planet. So, I mean, it's one-stop shopping. You can jump in a little muddy hole and come out with information that's of value across different disciplines. And like I tell my students, if you can't be smart, be first. So it's one of the places
Yeah, that's
on our
one way to do it.
planet. Yeah, that's one way to
Yeah.
do it. So my students are smart, but in my case, it's trying to be first.
Well, let's talk about why did you go into something so dangerous? I mean, just as background, it just because people probably have not seen all your videos, but basically what Dr. Broad does, one of his biggest claims to fame is he does deep water cave diving in these super black holes where you can barely fit, where there's zero margin for error, where one wrong move and you're basically dead. What would make you go into this field? Was there like a seminal moment that you had that would make you do something so dangerous?
I guess I'll go to great lengths to avoid faculty meetings and cell phones and email. And I found that was the most remote area I could get to. So, and balancing relative stress, it's actually quite the opposite. I mean, the way you describe it, it's accurate, but it also seems to emphasize almost the adrenaline aspects or the, constant fear aspects of the endeavor, when in fact it's the opposite. It's almost, you're in the state of what some people, have written about and referred to as flow, or peak experiences, where it's rather euphoric. You're in this altered state of consciousness, and you really are completely, I mean, it's, I guess to put it in sort of Maslow, the psychologist terms, it's almost an avenue to self-actualization. I know you've had past sort of wellness speakers and luminaries on your show, and it really is a way that you get into the zone, and it's all about your breathing. It's about your heart rate. It's all about your multitasking in a way that you don't even know how much time passes by, in that sense. So I gave you as I was saying before, I gave you the rational reasons for doing it, but I think it really is a way that I can reset myself for being able to handle the everyday humdrum sort of stresses above ground, and it puts things in perspective too. You really get a sense of the value of life.
Well, I mean, take us through your typical crazy, dangerous, deep cave dive, like the preparation. Tell us a little bit about how deep you're going, how small and dark these holes are. What is the margin for error? What's your backup plan? What if the proverbial shit hits the fan?
Gotcha.
So.
Yeah, and listen, we're just speaking one-on-one, but the science that I represent, the expeditions I'm on, those are really team efforts. And as much as, a long dive might be, let's say, 4 hours, some dives even much longer, but the bulk of the time you're spending on the surface with people. So it's really about the entire expedition experience. And it's about problem solving, and it's about what you alluded to, I think, risk management, right? It's thinking through every single possible thing that can go wrong that's at least within our control. And when you talk to people about cave diving, they're like, well, what about what about cave-ins? What about, crazy animals? What about these sort of out of control aspects? And that's really, if you look at it from a quantitative accident analysis standpoint, very few accidents occur because of things that are outside of our control. Same in aviation, same in other sort of high risk activities. It's usually human decision making. So there's certainly the redundancy in gear. I'm sure the same when you're in the surgical theater, right? For physicians, you don't just, oh shoot, where did I put that scalpel? Right? You happen to lose it, right? You've got backup of all sorts of equipment, and it's same, you have everything down to a backup mask, backup fin straps, whatever it takes, because you're not coming up, right? You have to go out what might be, miles underground to make your way out. So in that sense, it's about redundancy and risk management and equipment, and that can translate also onto the surface in terms of thinking about things that as humans we often don't have a good balance between what's objectively threatening and risky versus what subjectively we experience risk as a feeling. So that's, I'm to be, and this is not being, flippant, I'm often, particularly if I'm diving, let's say in Florida, where we know how Florida drivers are, right? I'm more worried about driving on I-95 5 hours to a dive site than I am doing the actual dive. And then once you're on the dive, assuming you've done all the proper training, you follow the critical rules of redundancy and always running a continuous guideline to the surface, again, having backup lights, backup breathing sources, backup computers for decompression, all of those, sort of technical equipment backups, then it's really when you start getting into the tight stuff, the very long or deep stuff, it then becomes really a psychology. A psychology and training and breath control. It's all about your breathing. I mean, as I'm sure everybody knows, when you start getting stressed, your heart rate goes up, starts releasing different chemicals in your brain, and your thinking isn't as clear as you'd like it to be. So there's I think an unstated, I wouldn't call it a rule, but when things start going bad, the first thing I do, and I know others do, is take what they call sanity breaths. So, I may only have 50 breaths left in my scuba tank, but I'll take 2 or 3 breaths just to keep my heart rate down, to get my respiration down, to think clearly on how to approach the problem. So again, not to keep repeating myself, but these are the sorts of lessons that also translate into the surface, particularly faculty meetings and at family dinners.
Yeah, I mean, but I think people need to realize, like, if things go wrong down in those deep caves, how long does it take for you to come to the surface? You can't just come to the surface.
No, you have to come out the way you came in. So, if you went in 5 kilometers, you've got to come out 5 kilometers. And often you're coming out with visibility that's much poorer when you went in. So the way you manage your diving gases, you might only use a third or a quarter going in, and estimate a third or a quarter coming out, but you save the rest for emergencies in case things get slowed down for whatever reasons, including leg cramps, including you're underwater for several hours kicking, or sometimes you're riding a scooter. So it has, and for me, one of the things I like about it is, or love about it, or am obsessed with, it's got the combination of the technical, right? You're mixing, you're learning about chemistry to learn about different gases. You're learning about physiology because there's decompression sickness and other potential physiological effects. You have to keep yourself in decent physical shape. And then it's got the mental aspect of keeping control of stress and really getting in tune with your breathing, which I think we all understand how critical that is.
Yeah, I mean, no, it sounds super intense, and we'll get into some more details later. But one of the things that I was reading is that you talk about the golden rules of cave diving versus open sea diving. What are some of those golden rules, as you call them?
Right. So for scuba divers, and I guess I should probably have started off the talk with the disclaimer, anyone who's not trained in cave diving, even if they have thousands of hours and thousands of dives in open water, should not venture into an underwater cave, because they're really completely different activities where it's different skills that are needed. But based on accident analysis over many years, it's been determined that there's pretty consistency in why people die in underwater caves. And I mentioned some of them before, but not running a continuous guideline to the surface, because what happens is you go into something crystal clear, and you're either, if you're using open circuit, your bubbles actually are dislodging sediment from the ceiling, or your fin kicks, or even just pressure waves of your body moving through are stirring up extremely fine sediment. So you're going into, as far as your light can see, it may be well over a couple 100 feet, and you turn around and it's zero visibility. You can put that same light against your mask and it's just a dull orange glow.
Yikes.
So people get, I think our evolutionary instinct to see what's around the corner draws people into these places. But again, without running a line that you can follow with your finger around it as a guideline on the way out, it leaves you in this, horrible maze of darkness. So continuous guideline, and then backup breathing systems. So not only do you have multiple tanks with you, they're independent, so that you can draw on one. You might just use, again, a third of one, then you switch to a third of the other. So if one fails, you still have 2/3 left in the other tank to make your way out. And again, that goes backup systems to almost everything. Very critical is backup lights. Back in the original divers were just going in with one flashlight, and we know how we've all had flashlights go out on us, and it's bad enough when you're, changing a spare tire on the side of I-95, but it's really bad when you're underwater. So you have, a minimum of three, but we'll often take five or six lights. So it's again about this backup system. Having the proper training is another one of the golden rules, and not diving below a depth on certain uh, beyond before getting certain types of deeper diving training where you learn to use mixed gases. I think, as you all know from working with anesthesia, any inert gas under enough pressure can become um, narcotic, right? So they call it Martini's law in diving. If you start going deep, breathing air, that nitrogen will have a narcotic effect and affect your judgment. So a lot of people, they might have all the equipment, the training, but they go too deep and it throws off their judgment. So that's another. So those are, I'm not great with rules, but those are the ones.
Those are the ones you remember.
Those are the ones I remember.
Yeah. So, I guess people could ask, why visit these caves? And I guess your whole point is that there's so much information that we can learn from in these deep underwater caves. Give us some examples of what is the type of information that you find when you do these deep cave dives.
So, and again, when if I use the word me or I'm working with all sorts of great scientists. So to give you one example that's close to home here at University of Miami, I work with Peter Swart, who's a geochemist. And he's not a cave diver, but he'll be with us and help direct what we do underwater in terms of the type of geologic samples that we need to bring up that he can bring back to the laboratory out at the Rosenstiel School. And again, look at the different, the isotopic chemistry and the ratio of different isotopes. He can study that there's actually Saharan dust embedded in these speleothems. That's the stalagmites. Those are the ones that grow from the bottom upwards. And try to understand, wow, when we had mega droughts, for example, in the past, what was driving them? Why do we have these massive amounts of Saharan dust in this part of the world at this time? We know, we get regular inputs of Saharan dust in South Florida and the Caribbean. In fact, it's one of the reasons why the Caribbean without industry has high asthma rates, right? But the quantities that we're seeing it in past periods of time can help us understand the sort of global dynamics of air circulation and climate, and how CO2, carbon dioxide and the other greenhouse gases have led to some rather abrupt changes in the climate. And not to, without getting into the weeds, and let me just say that some of the findings from the samples we brought back should make us even more worried about greenhouse gases and CO2. Our atmosphere is very sensitive to perturbations, and in the last 100 years we've done a number with CO2, and I think we should all be worried about that based on what we understand from natural climate variability as well. So those, there's fossils, a lot of, particularly in places like Florida, like the Caribbean, Bahamas in particular, they're very low lying, right? We're only a few feet above sea level on average. And we've had, thousands of hurricanes over the years. So the archaeological, paleontological record, right, of bones, they've been in many ways wiped out, right, washed away. But if you put them in a blue hole, they're safe and sound for thousands of years. So all around the world, actually, caves are a repository of fossils. I mean, we know that from the human fossil record in Africa as well. Many of the big finds are deep in caves as well. And from a human standpoint, caves have always been attractive as this sort of liminal space, right? Our connection to another world, the underworld, to other forms of life. And I wouldn't put it in the traditional sort of Judeo-Christian religious sense, but you do have this feeling of being in another world, and that you're connected to a larger sort of physical network that's outside the human realm when you're in these places. So again, we're talking about the science. We're at university. It's nice to justify our paycheck in scientific terms, but really it is about this this feeling that you get that's a little bit hard to describe. But again, I think some people call it these peak experiences or flow. It's just interconnectivity that you feel. And probably safer to get it doing yoga or meditating. But I got stuck. I got stuck with cave diving.
I mean, tell us the most extreme situation that you've ever been in deep cave diving, if there was one that you could pick.
So there's extreme situations, and then there's some extreme situations that didn't go well.
Why
Which
don't
one
we
do you want?
do extreme situations and then we'll talk about the one where, the craziest, most life-threatening one.
I mean, this is one of the, well, I can probably combine them in one, but early, kind of relatively early on in my career, early 1990s, I was actually the youngest on an expedition to the Oaxaca region of Mexico, to a place called the Huatla Plateau, where the deepest known dry cave in the world was. So this was a multi-month expedition. You spend increasing amount of time actually living underground in a dry cave. And the bottom part of this dry cave, you can almost think about it like a drain, and where the very bottom of the drain, the water collects, and that's where you start the diving. And we were using sort of experimental rebreathers and all this sort of fancy gear. And we sleep on hammocks that are bolted into the walls on the rocks right above the water. And there was a roaring waterfall, and I had headgear on, and it was earplugs in. And I got up in the middle of the night, which is, again, it's sort of always night in a cave, right? And this is, well over 4,000 feet underground. And to go relieve myself, but instead of going, you don't go in the water that you're about to dive in that you use for cooking. It was in a little Nalgene bottle, right? That we hike everything out of the cave with. Anyway, I went to go get back in my little skinny hammock and sort of flipped backwards and hit my head and went over about 15 feet or so into the water, and just completely dazed and, almost unconscious. And that really was one of my closest calls. And again, it wasn't the way you would think it would happen. Again, it's this objective risk versus perceived risk, and it's not. I'm not claiming that, in broad brushstrokes, that urinating is more dangerous than cave diving. But again, it's these near misses driving in other countries, driving on 995, getting to the sites, that they're often truly the closest calls I've had. There have been times underwater where, we've had, reversal of currents unexpectedly and some other issues like that. But in some ways, and just from the training, you click into being calm, and it's only after the fact you realize how, maybe you were closer than you realized you were. But I think the ones where I said, oh my gosh, those were not even really in these most extreme moments. And that's the way I think a lot of accidents happen. When we're in our extreme dives, we've done visualizations, we've done all these exercises, we've done scenario planning, we've done dry runs on them, we've done test dives, and we're in the mode, right? It's when you let down your guard and these others, other sides of that are all affiliated or all part of exploring, I think that's some of the most dangerous.
Yeah, I mean, I think that you said it best, and someone just commented here, like when the shit hits the fan, so to speak, like the natural human reaction is to flip out, heart rate goes up, breathing goes up. It's like a fight or flight, which is obviously instinctual and normal to have that feeling. But pretty much in your job and any other high intensity, high stress job, you need to keep calm. So again, just take us through what your routine is, especially in your job when it's life or death. And obviously making a bad decision or freaking out and not thinking correctly means you're dead. How do you keep calm? How do you think clearly when it's so life and death and so critical?
I think there's the sort of breathing techniques, what I mentioned before, taking the sanity breaths when you do get to those critical moments. I can give you an example. My main dive partner is his name is Brian K. Cook. He lives in the Bahamas, and he's just an amazing explorer. And I learn every time I dive with him, I learn something new. And he was a Navy diver and doesn't have formal scientific training, but he's found many more species. He's just an amazing individual. But we were diving, and often we'll get to a point and we'll split up, or it looks too small for two people to go in because you can't back out when you're all jammed up with two people. So he went in first and was gone for a while, and I started getting a little bit nervous, and then I started to poke in, and he realized he was in really tight and in a situation where if I was there, it would have been really hard to deal with. And I started getting nervous. I could feel my heart rate going up. It's one thing, it's worse when you're worried about someone else than you are about yourself. And then you also get into a situation where you're thinking, okay, I don't want to have to leave this person, but at a certain point, I need to, you know, save myself. So ultimately, what happened is he thought he was getting very nervous because he thought I followed him in because he was hearing things, but he was just hearing sort of my exhalations that were reverberating into this very small area, but I wasn't going in too far. Anyway, to make a long story short, he made it out, and we regrouped, and now we have a system where if one of us is going in, we can, because sound travels well underwater, we use that beeping sound that you hear when trucks back up, beep,
Mm-hmm.
beep, beep. So it's ways that you can communicate and lower stress. So a lot of it is about communication ahead of time to even in the most stressful, and it's about humor. So we use the beeping. We have all sorts of, even in sort of what would seem like terrifying situations, if you can insert humor, it brings down the tension both on the surface before a dive, particularly if you're with someone who you can sense that nervousness, or in the water. Even joking around will pull each other's mask off at a bad time, or you'll mess with someone's equipment a little bit, something that's not going to be, certainly not going to be fatal, but it's enough to sort of break that tension. So I think some of the same things, gallows humor that people have in emergency rooms, all that all comes together with a physiological training, I think, to keep you from going over the edge. I don't know, is that answering more or
Yeah, no,
less?
I mean
Right? Yeah.
those are actually great lessons, I think, for anyone who, even if you're not a extreme deep underwater cave diver, I think those are great lessons for life. And I think just keeping your cool in high stress, high impact situations is going to lead to better outcomes. I think that's a phenomenal lesson. What is the single most important scientific discovery that you've been a part of, if you could pick one?
It's hard to pick one because for the archaeologists, it's what they're interested in. For the microbiologist, for me personally, I think it's if we have to go with traditional science, I think it's what it's taught us about climate change, and really reinforcing, I think, the critical nature of what we're facing on a global scale. It's you really, when you see the process of science from start to finish, from exploration through to the laboratory, and I mean, we know it being in the university setting, but you really realize the apolitical nature of it. And this isn't, we're not out to prove something ideologically. We're going in there with very open minds, but what we're coming out of certainly support what we're all worried about, what many of us are worried about with climate change. And I know we haven't talked about filmmaking very much, but I will say that being in the scientific world, it's really becoming, and one foot in the science world, one foot also involved with many films, documentary type films and other films. You really realize what's motivating people tends to be less the science than it is, coming back with imagery and proof and sort of the storytelling narrative about how we understand what's going on with climate change. And that's been as satisfying as the scientific findings, is being able to share this imagery, especially with audiences that might be skeptical of the scientific method or the process, or what's going on with climate change, because they see it so highly politicized. But if you can show this information through telling an exciting story about extreme cave diving and risk, and make it personable, but also sort of get into the nitty gritty of how we do this, that's been, I think, as important to me as the sort of empirical finding of whether it was 300 or 310,000 years ago, where we had extreme cooling to warming to this or that. So,
yeah, I mean, I think that's why National Geographic is one of the most watched channels. It's because people obviously love seeing that extreme filmmaking stuff that 99.999% of us will never see. You get to see that and you feel like you're at least living vicariously through, crazy scientists like yourself. So, looking forward, where do you see the future of exploration with the advancements in technology? What remains to be explored, and where do you see the next 5, 10, 15 years going?
well, certainly we've only sort of scratched the surface with underwater caves and even caves in general, and there's a lot to learn down there. I mean, if you take away all the water that's locked up in ice, more than 95% of the world's fresh water is beneath our feet in groundwater. Florida in particular, right? We have one of the largest groundwater, underground reserves, aquifers in the world. So we know very little about these areas. So I think there's some hydrological work to do, certainly. Outside of cave diving, I think more generally, there's a lot of places that we need to go back to, because now we have, whether it's advances in DNA analysis, whether it's advances in the laboratory for doing different geologic purposes. And I think on the more ethical side, it's been primarily sort of colonial Western countries that have come into other countries to do work. Whereas I think working with and working for some of the home countries to find out what are their issues, what are their needs, how can we share some of these technologies and skills that I think, we've been in this privileged place to use. I think that's very much the equity aspect of exploration is what needs a lot of attention, and I think it's finally starting to slowly shift that way. So it's going back to the same places, but with new technologies and with a new, I would call it, moral compass guiding us, will go a long way.
So let's say there's a 15, 20-year-old kid who wants to be an explorer. What's the advice you'd give them?
Okay, don't listen to your parents generally. I mean, that's the first one. It's probably a good idea to go to school, but it's not necessary. I think a lot of the major finds have been done by people who are just passionate, amazing observers, pattern recognition, reading on their own. I think generally the formal education system isn't the only way to go. Works well for some people, not so great for others. So don't feel limited that way if you're not a good student. For sure. Just if you're passionate about something, particularly in this day and age when so much is available on the internet, you can really learn skills, you can invent things, and just get out there one way or another. Do it. There's people, the citizen science potential is never been greater. So I think it's cliche, but I think it's about following your passions.
Yeah, I mean, that is beautifully said, and obviously you're just a huge example of that. We are well past time. I'm going to let you go because I know you're so busy. I just want to reemphasize that just for all our listeners, they're literally getting 1% of what you do. I definitely recommend people go online, search Kenny Broad. The videos are insane. The stuff that he does, this deep cave diving, the extreme filmmaking, National Geographic Explorer of the Year. It's truly mind-boggling. I was watching it and I couldn't believe what I was watching. So definitely recommend everyone go and watch that. Kenny, again, thanks you for your time. I want to thank all our listeners. And again, this episode and all the other episodes of the podcast are now streaming live on the Crossover. So we look forward to having another episode next week. Thanks a lot, Kenny. Really appreciate your time.
Thank you. Be safe, everybody. Thanks so
Take care.
much.